here we have the frequency counter counting to 231. And the circuit is this voltage controlled oscillator with the CD4046 phase locked loop IC, and the potentiometer on the top is controls the voltage for oscillation. So as you can see, it's still a pretty stable circuit. The purpose of this video is to illustrate a four-way AND gate, which is done through these four transistors right in the middle of the screen here. And the way this circuit is run is these transistors are wired in series, and power, or Vcc, is going to the collector of the first transistor. The emitter of the first transistor is connected to the collector of the next transistor, and so on and so forth. The final transistor is connected to ground with a 100 kilo ohm resistor, and off of that is this orange wire right here, which is running to as the output to the counter. The input to the transistors is going in through these resistors right in the middle of the screen. There's four resistors, and these are outputs from the clock. And right now I have it set to read a value of 3,456. So the 3 from the 1000s place, which is on this last CD4017 counter, is being fed through that white wire, through a transistor, and into the base, or through the resistor, and into the base of the first transistor. And the 4 from the hundreds place is going through the second one. The 5 from the tens place, I'm sorry, the 5 from the tens place is going to the third transistor, and the 6 from the ones place is going to the first transistor. And so when all of these are on at the value of 3,456, that goes into the frequency counter. To measure the accuracy of this, I still have this set to about 800 kilohertz. 800 kilohertz, which is 800,000 cycles per second, divided by 3,456 is 231. So I'd say this clock is fairly accurate, and the counter and the AND gate, the four input AND gate with transistors, is working. The reason I'm using the number 3,456 is because that's the number of bits, total bits I have to send to these WS2812 neopixels, addressable neopixels, and I have 144 of them. And so each one of these takes an 8-bit value for red, green, and blue, which is 24 total bits per LED, and 24 times 144 is 3,456. So at the moment, with that four-way transistor-based AND gate, I can get to the number 3,456 at 800 kilohertz, which will precisely deliver that many bits to all these LEDs, and then I could do something else with it after it's displayed. So it's jumping up and down a little bit, but for the most part, that is a rock stable circuit. As usual, I'm using these CD4017 decade counters, which do the job very well. These counters are the best counters ever. And this CD4046 oscillator is doing the job as well. It really is a rock stable oscillator if you provide it with the exact voltage that it needs. In this case, the voltage that makes it go at 800 kilohertz with my timing, so with my timing circuit, with the capacitor and everything, is exactly 3.62 volts, and it definitely does the trick. So next phase of the completely microcontroller free WS2812 display activation, neopixels of these neopixels, is we'll make it in the next video. So thanks for watching as always.